All right, so get this.
Okay.
Imagine building an AI as powerful as the ones used by like the big tech giants,
Right.
but for a fraction of the cost.
Yeah.
That's exactly what DeepSeek-V3 has done.
Uh-huh.
And today, we are going to dive deep into how they pulled it off.
Sounds good.
Now, you might be thinking,
Yeah.
hold on, I'm a software engineer. I'm not an AI guru.
Right.
But trust me, this is relevant.
Okay.
Even if you don't spend your days, wrangling neural networks,
Sure.
DeepSeek-V3 is a powerful language model.
Yeah.
Think of it as a program that can understand and generate human language.
Okay.
And its development reveals a lot about where AI is headed, what it can do,
Yeah.
how it's built, and get this, how much it costs to train.
Okay.
Our sources today are a technical report on DeepSeek-V3
Right.
and a tweet that really caught my eye.
Oh.
It's from AI expert Andrej Karpathy.
Okay.
And he calls the model's training cost a joke of a budget
Wow.
compared to what companies like Google or Microsoft typically spend.
Interesting.
So let's unpack this joke with our expert
Okay.
and see what makes DeepSeek-V3 so special.
The first thing to understand is that DeepSeek-V3 is a massive model,
Okay.
boasting a whopping 671 billion parameters.
Okay, pause right there.
Yeah.
For us non-AI folks,
Sure.
what exactly does a parameter mean in this context?
Think of parameters as the connections in the model's brain
Okay.
that allow it to learn and process information.
Okay.
The more parameters,
Yeah.
the more complex the model can be.
Okay.
But here's the kicker.
Right.
DeepSeek-V3 is built on something called a mixture of experts,
Okay.
or MOE architecture.
MOE.
Yeah.
Now that sounds like something out of a sci-fi movie.
It's actually a really clever way to make these giant models more manageable,
Okay.
instead of one massive network trying to do everything.
Right.
Imagine having a team of specialized experts. That's essentially what MOE does.
Okay.
It breaks a model down into smaller specialized units,
Okay.
or experts, that are activated only when their specific skills are needed.
So instead of having one giant brain trying to juggle everything, you have a team of smaller brains.
Yeah.
Each focusing on a specific task.
Exactly.
Kind of like dividing a complex software project into smaller, manageable modules.
That's a great analogy.
Cool.
And this approach makes the model more efficient to train and run.
Okay.
Which brings us back to Karpathy's tweet about the joke of a budget.
All right.
They trained this massive model using 2048 GPUs.
Wow.
Those are specialized chips designed for AI
Okay.
for just 2 months.
Uh,
And the total cost, mere $6 million.
$6 million might sound like a lot,
Right.
but I bet it pales in comparison to what the big tech companies are spending on AI.
You're absolutely right.
Okay.
Remember that model we mentioned earlier, Llama-3?
Yeah.
It required 11 times more compute power to train
Right.
than DeepSeek-V3.
Wow.
So we're talking about a dramatically smaller budget
Okay.
and a significantly shorter training time.
That's crazy.
This begs the question,
Yeah.
how did they pull this off?
Yeah. How?
Well, that's where things get really interesting for software engineers like you.
Okay. I'm all ears.
All
I
right.
love a good efficiency story.
Okay.
Spill the secrets.
The secret sauce lies in a bunch of innovative approaches that they detail in their research paper.
Oh.
One key factor is something called FP8 mixed precision training.
Okay.
It's a bit like compressing a large file without losing any important data.
Interesting.
Yeah.
So they found a way to represent the numbers the AI crunches
Right.
in a more compact format without sacrificing accuracy.
Exactly.
Oh,
It's like optimizing code for performance, but on a whole different level.
wow.
Another innovation is something called auxiliary loss-free load balancing.
Okay. I'm going to need you to break that down for me.
Okay.
That sounds a bit intimidating.
It's actually simpler than it sounds.
Yeah, okay.
Remember those specialized experts we talked about? This technique helps distribute the workload more evenly across those experts
Okay.
without sacrificing the model's accuracy.
Okay.
It's like having a good project manager who makes sure every team member is contributing effectively.
Makes sense.
Yeah,
So it's not just about raw computing power.
right.
It's also about clever algorithms and techniques.
Absolutely.
Gotcha.
And they didn't stop there.
Oh,
They also came up with something called multi-token prediction.
okay.
Imagine you're trying to guess what someone is going to say next.
Uh-huh.
DeepSeek-V3 can predict multiple words at once.
Really?
Kind of like reading ahead in a book.
Wow.
which makes it much faster.
Yeah.
And on top of all these algorithmic innovations,
Yes.
they meticulously optimize their hardware and software infrastructure.
Mm.
They manage data transfer between those GPUs like a well-oiled machine, eliminating bottlenecks and squeezing every bit of performance out of their system.
So they've taken a truly holistic approach to efficiency,
Yes.
and it's really impressive. It's like they applied the principles of good software engineering to the world of AI,
Yeah.
optimizing at every level. But at the end of the day, efficiency is just one part of the story.
Right.
The real question is,
Yeah.
does DeepSeek-V3 actually work?
Right.
What can it do?
Now that's where things get truly exciting.
Okay.
Let's dive into DeepSeek-V3's impressive capabilities
All right.
and see how it stacks up against the competition. DeepSeek-V3 excels in several areas, particularly those that align with its training data. Remember how we talked about it being trained on a massive data set of text and code?
Yeah, it was like giving the model a crash course in human knowledge with a heavy emphasis on code and math.
Exactly, and that training really shines through in its performance. For instance, in tests like Human Evil and MBPP, which evaluate how well a model can generate code, DeepSeek-V3 consistently outperforms other open-source models. It even achieves performance comparable to GPT-4 on some of these tasks.
Hold on, you're saying this model trained on a joke of a budget is going toe-to-toe with a model from OpenAI,
Yeah.
a company with significantly more resources. It's pretty mind-blowing.
It is. It really speaks volumes about the efficiency of DeepSeek-V3's design and training methods.
Okay.
They've managed to achieve near-frontier performance with a fraction of the computational power.
That's super impressive.
Yeah.
But how does it handle other tasks, like understanding everyday language and figuring things out, tasks that aren't just about code?
It performs remarkably well there, too, on tests like MMLU and CEVAL, which cover a wide range of topics, from history and science to literature and even common sense reasoning. DeepSeek-V3 scores highly often, exceeding the performance of other open source models and even approaching that of some closed source models.
So it's not just a one-trick pony. It's a versatile model,
Right.
capable of handling a variety of tasks. That's really exciting, especially for those of us who aren't AI specialists but are curious about its potential.
Absolutely. Of course, it's important to remember that no model is perfect.
Right.
DeepSeek-V3 does have its limitations. For example, while it's great at understanding long chunks of text, its performance on factual knowledge benchmarks isn't as strong as some of the leading models out there.
So it might not be the best choice for, say, powering a fact-checking website.
Exactly. But it's important to keep in mind that DeepSeek-V3 was primarily trained on a Chinese dataset.
So its knowledge of facts might be skewed towards information that's more readily available in Chinese. That makes sense. It's a good reminder that a model's strengths and weaknesses are often shaped by its training data.
You've hit the nail on the head, and to their credit, the DeepSeek team has been very transparent about their model's limitations.
That's good to hear. Transparency is crucial in the AI world, especially as these models become more powerful and have a greater impact on our lives.
Right.
Speaking of impact, what are the broader implications of DeepSeek-V3's success? What does it tell us about the future of AI development, especially for software engineers like me?
That's a great question. DeepSeek-V3 challenges the notion that you need massive resources to make significant contributions to AI. It's a sign that the AI landscape is changing. We might see a shift away from the bigger is better mentality that has dominated the field for so long.
So it's not just about throwing tons of money and computing power at the problem anymore.
Precisely. It's about being smart with your resources, developing clever algorithms, and optimizing your infrastructure, much like you would in a well-engineered software project. DeepSeek-V3 proves you can achieve remarkable results with a more focused and efficient approach.
That's really encouraging for smaller teams and individual developers who want to get involved in AI but don't have access to the resources of a Google or a Microsoft. It feels like AI development is becoming more accessible.
That's a great way to put it. DeepSeek-V3 is like a beacon,
Yeah.
showing that you don't need a billion-dollar budget to create a highly capable language model. This could lead to a more diverse range of people and organizations contributing to AI, which could accelerate innovation in the field.
That's an exciting prospect. More people bringing their unique perspectives and ideas to the table can only lead to good things. But it's not just about the hardware, right?
Right. DeepSeek-V3 also highlights the crucial role of efficient algorithms and high-quality data.
Okay.
It proves that there are still significant gains to be made in these areas, even without resorting to brute force computation.
So it's a combination of clever engineering, smart algorithms, and good data that's driving progress in AI.
Absolutely. And that's a valuable lesson for anyone working in AI, regardless of the resources they have at their disposal.
Okay, so far we've covered a lot of ground. We've explored DeepSeek V3's impressive capabilities, its efficient design, and even its limitations. But I'm curious to pull back the curtain even further and understand how this model actually learns.
Let's do it. The training process is fascinating, and it involves several steps that are surprisingly similar to how we humans learn.
All right, so let's talk about this AI training process.
Okay.
It sounds like it's surprisingly similar to how we humans learn.
It really is just like we need textbooks and teachers to learn. AI models need data.
Okay.
In DeepSeek V3's case, its learning journey began with a massive amount of text and code, a whopping 14.8 trillion tokens, to be exact.
Okay, remind me again, what's a token in this context?
Think of it like a building block of language.
Okay.
It could be a word, a punctuation mark, or even a single character.
Okay.
So 14.8 trillion tokens represents a mind-boggling amount of information.
That's a lot of data to digest.
Yeah.
What kind of content did they feed into this AI?
They aimed for a diverse and high-quality collection drawing from sources like Wikipedia, programming repositories like GitHub, and even mathematical texts.
Interesting.
They essentially provided the model with a comprehensive overview of human knowledge, particularly in the realms of code and math.
So it's like they gave DeepSeek V3 a crash course in all sorts of subjects.
Right.
But with a heavy focus on things that software engineers would find useful.
Precisely. And to ensure the model could learn effectively from this massive data set, they used a technique called document packing, which allowed DeepSeek V3 to process entire documents, preserving the context and relationships between different pieces of information.
That makes sense. It's like reading an entire book instead of just skimming random sentences.
Exactly.
You get a much better understanding of the overall story.
Right. But gathering and feeding data is just the first step.
Okay.
To really unleash the model's potential, they fine-tuned it using a technique called supervised fine-tuning, or SFT for short.
So SFT is like giving the model specialized training for specific tasks?
Yeah.
Kind of like how we might take specialized courses to develop specific skills?
That's a great analogy.
Cool.
They created a data set of 1.5 million examples each with a clear instruction and a desired output.
Okay.
This could be anything from solve this math problem to write a creative story about a robot who dreams of becoming a chef.
So they're essentially showing the model what good output looks like for a variety of tasks, guiding its learning process?
Exactly. And for more challenging tasks that require complex reasoning, like generating code or solving tricky puzzles, they used an even more advanced AI model called DeepSeek-R1 to create training examples.
Wait, they used AI to train AI?
It is.
That's pretty meta.
DeepSeek-R1 is a model specifically designed for reasoning tasks. So it could generate high-quality examples that demonstrate effective problem-solving strategies.
It's like having a super smart tutor guide DeepSeek V3's learning process.
Precisely. But they didn't stop there to refine DeepSeek V3 even further. They incorporated something called reinforcement learning, or RL. It's a bit like training a dog with rewards and corrections, but instead of treats and scolding, they use data and algorithms to guide the model's behavior.
Interesting. So how does that work in practice?
For tasks with clear right or wrong answers, they used a rule-based system. Think of it like a set of clear guidelines that tell the model, this is good or this needs improvement. But for more open-ended tasks, they actually used another AI model as a judge, evaluating the quality and relevance of DeepSeek V3's responses.
So they have AI evaluating AI. It sounds incredibly complex.
It can be.
But all this training seems to have paid off. DeepSeek V3 is now capable of handling complex reasoning tasks and demonstrating a deep understanding of language.
You're absolutely right. All this careful training and fine-tuning has resulted in a model that's not only efficient, but also remarkably capable.
So what does this all mean? What are the key takeaways for our listeners, especially those of us in the software engineering world?
DeepSeek V3's success is a powerful reminder that you don't need unlimited resources to create impactful AI. It's about clever engineering, efficient algorithms, and high-quality data.
It's like what we strive for in software engineering, finding elegant solutions that maximize performance without breaking the bank.
Exactly. And it also shows that the AI field is becoming more accessible.
Right.
You don't need a billion-dollar budget or a massive data center to contribute.
That's exciting.
Yeah.
Who knows what kind of groundbreaking innovations might come from smaller teams or even individual developers now that the barriers to entry are lower.
Indeed, DeepSeek V3 is more than just a powerful AI model.
Yeah.
It's a sign of things to come. It signals a future where AI development is more inclusive, diverse, and driven by innovation rather than just brute force.
That's a fantastic note to end on. It's been an incredible deep dive into the world of DeepSeek V3.
It has.
We've covered a lot of ground, from its efficient design and impressive capabilities
Right.
to the surprisingly human-like way it learns. We hope you've enjoyed exploring this fascinating model with us.
Yes.
Until next time, keep learning, keep experimenting, and keep pushing the boundaries of what's possible.